guys, hope you can hear me fine here. First off, let me start my talk with asking a question. How many of you here have ordered a food that a robot has delivered? Okay, not a lot. I'm hoping that this talk will give you some insights and also encourage you to go and get a delivery coming from a robot. So what I'm going to be talking and covering in this presentation is kind of fourfolds. One is, what is Serve Robotics and what's the scale of operations that we are at right now? And what are some of the nuances and interesting experiences that we have had from the real world operation? And we want to share a little bit of our current approach on how we are approaching autonomy while being operationally efficient, and also wrap it up by what are the future directions that we are going after with. And one of the interesting things is we actually acquired Vayu Robotics, who's also going to be talking later this afternoon on sharing some of our end-to-end and foundational approaches that we are taking with the enormous amount of data that we have curated so far. So let me get started. Serve is a spin-off from Uber. And currently, we are one of the largest AV fleets, and we are going to have 2,000 robots in the field by end of this year. And what we do, we are solving the last mile autonomous in our neighborhood. Like, how can a robot be helpful in the last mile sector? Currently, we are rapidly growing. We are a public company right now. We are having a 40% quarter-over-quarter growth in our deliveries. We are actually delivering from 2,500 restaurants right now. We have done more than 100,000 deliveries. It's rapidly growing. And till date, we have close to 500 plus robots that are deployed across US. And this is our current operational footprint. LA is our bread and butter. We have a large neighborhood that we are operating in LA. We are also expanded to Dallas, Atlanta, Miami, and Chicago. So if you're in those areas, highly encouraged to get the experience of a robot delivering a food. And another quick tidbit here, every robot of ours has a unique name to it. So you can actually message us saying, hey, this robot Francis or robot Rajesh, did this job. Maybe you like it or did not like it. You can get back to us that way. Not only we are scaling our operations and actually increasing our footprint of delivery, we are also going to be one of the largest. We are going to have the largest spatial data in this world, probably in a year from now. And currently, what we are looking at is we are collecting close to 1 million miles of data per month, and that equates to 170 billion data of image, which has image and LiDAR together. And it's accounting to close to 60,000 terabytes per month. And this is probably going to be fueling most of our future AI work that we are going to be encountering into. And I'm sure there's another talk coming later this afternoon that we'll go in deep on that one. Today, with this data, we are not only just having the data, but we have HD maps. We are also re-registering the world around us, and it gives you direct 3D geometry and fusion information, and also motion information of what we are seeing in this world. It's going to be pretty exciting. OK, so now that we talked about the scale and growth of us, I want to share a little bit on some of the autonomy challenges. One of the things I want to highlight is the ODD that we operate on is one of the most unstructured and difficult ODD to really have a good perception and behavior plan. And in this example, I'm highlighting some of the things. For example, you have a sidewalk that's unstructured. You have to go over bends and dents and tree wells that's uneven. You have no concept of lane. You have a lot of people walking around. For example, in this image, I'm sharing the image of a Hollywood street where we actually operate our robots today. There's going to be bicyclists, there's going to be strollers, there's going to be people and family who's having their kids walking around. There's also going to be, dogs that are going to be chasing our robots, which is another interesting thing. And there's also going to be a lot of clutter. For example, you will have pedestrians in different poses that we have to detect and solve for. Not only is the ODD nuanced, there's also a lot of social nuances. So let me just quickly play this video. And this is actually a footage from our robot that we see. So you can see here, there's a family who wants to take a selfie with a robot. Now, this robot is in a delivery, so it's actually stopped because these people want to take a picture. And the dog there wants to chase us, and this is the fun one. Someone wants to surfboard with a robot, right? They're just like hanging out with a robot while it's moving. Now, these are the problems that we're exposed to in real world, right? Like one of the insights for me is, while we talk about models and how hard it is to build a model, to me, the realization is data and the reality of operations and real world is even harder. And somehow merging those two is going to be a big pain, because in the end, we want to build a product that humans can use through robots. So with the scale and with the data, I just want to share some of the lessons we have learned through our journey. And I want to just focus on one aspect, the aspect of solving social behavior and also being safe. Because like if you're putting a robot out in the wild, you got to be safe. You got to hit the high nines, like 4 nines or 5 nines or 6 nines. And the biggest aspect in the ODD of a sidewalk or crossing an intersection is the fact that you're having a lot of pedestrians, and the pedestrians can be in any poses and can appear from anywhere. So this is actually an output from our current AI model that's working. So just to give you a little bit of glimpse, you're looking at a risk map, we call it, which is kind of fusing the information from all your AI modules and HDMap modules. And let me play it a little bit so you can see what the robot is undergoing right now. So the robot is trying to move, but there's a cloud of pedestrian, and we have like tracking that's long-term, short-term, that's flicking, and the robot is trying to move, but it couldn't move because there's just a lot of pedestrians crowding around it. So how does it move? It's a problem that we need to figure out. The other thing I want to highlight here is your pedestrians can be in unexpected poses. This is actually a robot that is navigating and avoiding a pedestrian. You probably might not see it, but the pedestrian is actually lying down to the left of the robot. And the robot is detecting both from a safety system and also from a tracking perspective as it's navigating its terrain. Not only that, we have to deal with certain appearances. So for example, in this case, you can see that the robot is traversing and then someone opens the door and comes by, and you got to solve for this. So how do we solve? Because like, yes, we can think about, all these data is very useful, is very efficient, but you have business objectives that's threefold. A, you got to be safe. You got to build the trust that your robot is doing the right thing, and you got to be performant because you have a customer waiting for your delivery to come over. So given these nuances, what is our autonomy approach? What is our philosophy to solve autonomy for a sidewalk or for a last mile? Our current vision and strategy is, first off, we got to be safe. And not only being safe, you got to build a socially aware robot navigation for real world, because being safe can mean that you're not actually doing the delivery on time. Because the safest robot can be the robot just stopped, right, without any movement. But you got to build safety and socially aware behavior so that you can navigate and do the delivery on time, because that's what fuels your business. And for us, safety is not negotiable. Actually, I was there in this incident when this happened. We actually were testing pedestrian in different poses, and one of the poses that was very hard for us is lying down, right? Like you have people lying down all over the place, and we actually took it to the real world, because whatever you do in simulation, nothing kind of gives you that experience on what happens in real world. We actually put mannequins on the sidewalk in LA, tested how our robots are doing, and we didn't care about all the hush buzz that comes around the media. Actually, this became a big viral news. People took it to a political situation and kind of made a lot of news around this. But for us, the value is you have to have principle over perception. Like when it comes to indulging robotic, it's a very new field. People are kind of understanding how to use it. And you got to make sure that even though the perception is not right now, if you have a principled approach to solve autonomy, the adoption is going to come, because it's very new for anyone to think about it, right? And that way, our approach is safety is not negotiable. So we can't have anything that causes safety issue. So what it means, so the high-level architecture that we have right now is kind of a modular approach where we build in-house HD map, where we map the world that we are traversing, because our robots are having high fidelity sensors and LiDARs that you have like 4D registration that you can easily create. And we use that as one of the information that goes into a vector space, into this novel risk fusion format that we call. So the risk fusion is kind of your intermediary where it collects all your perception and the real world information, and it acts as a source to get your behavior and planner module act with that. And on top of it, you need to have a safety system also, because this one can be a type 2 system, but you need to have a type 1 system that's actually fast paced and actually reacts to the nuances of the real world. And following the localization, we have 3 other AI modules that are running. One is the semantic map, which aids, like your HD map gives you not only your localization, but it also gives you a raster space of, okay, what are the semantics of your terrain? Like, is there a sidewalk? Is there a road? Is there a tree well and whatnot? And you're also having an onboard AI model that's running and giving you the same redundant information. Because since we have a very strong safety redundancy approach, our methodology is always fusing these information together so that you are not like penalizing on the safe operation of your robot. And the other big AI module that we have to get really right, and it's a work in progress still, is how do you solve your pedestrian prediction problem, right? And the interesting fact is it's not just pedestrian prediction. Apparently in our ODD, cars can have weird maneuvers. Like it can come into a driveway, go out of a driveway. You're solving with intersections. You're solving with last 50 miles where you have cars parked all over the place. So you've got to solve all those nuances. Now, as this has a positive of this is kind of isolating your perception, prediction, and a behavior planning through this novel risk fusion layer, you still have information loss through this modular approach, right? And to me, there are 3 cons that are yet to solve it for us. And those are, your behavior module still gets complicated, because even if you have this conceptual risk fusion layer, your planner that's acting on that information has to listen to the behavior aspects of the real world. And I'll touch a little bit on that in the successive slides. And the second one is, how do you have a human-like maneuver? Like if a crowd of people are walking along with you, how do you make sure that the robot is actually not stopping? It just knows that it's the flow of traffic, let's just go with it. And it's much harder with pedestrian because you can't have a long-term track, because we are bipedal in nature, we can change our course anytime. So how do you really solve it? It's a concern that we have. And also predicting human intent is hard. Like I don't know what will a pedestrian do when they are walking. It's very hard to predict, right? So these are kind of like really hard problems, and also something that we need to solve to truly unlock a safe and a socially acceptable and a productive robot that can actually change the P&L of your robotic company. So my question to us is this, and I'm happy to kind of talk about this and share a little more insights on how we are solving it, and also love to hear from you guys on this. In this scenario, so take the first image as example. There's a robot, let's say that's a robot view where there's a kid in the view, there's a lot of bushes, and the kid is isolated from their family. Now, what should be the right behavior even though you have nailed down the perception? Should the robot go through and pass by the kid who's actually, we could probably brush them, we might not hit them, or we might have enough space to traverse? What will the family think? Should I pause and delay my delivery because my customer will be not happy with me? What is considered the right thing here? And these are the problems that we are solving right now, because we have the power of data. And because of our position in the public market, and also we acquired Vayu recently, who are coming in with very strong foundations on how to think about end-to-end modeling. These are the problems that we are solving right now, because this truly unlocks the end-to-end autonomy for us, because then it has real P&L benefit, it has product benefits, and it truly puts the stage that we are not only safe, but we are socially aware, and we can do the delivery on time, because all 3 are very important. With that, I'll probably say I'll say one more thing. Our current philosophy on how we approach autonomy is, as I said, safety is the #1 thing. We are modular by design today, and we have so much data that we are sitting on. And what we want to do with that data is truly unlock the potential of what current architectures can do. For example, all these transformer models, that's like tokenizing the world information into context. How do we fuse it with the in-house HT map that we have built? And we have already created close to like 350 miles of HT map data that we have. How do we really untap it? We can easily create a Gaussian splatting 3D world, 4D world. How do we use that information with the mindset that you have 2,000 robots that are ready to service humanity, and how do you solve the real last mile problem? And not only just for a wheeled robot, but a quadruped that can actually do the last 50 feet, where you can actually go to the door and do the delivery on that. And with that, I will encourage you guys to attend the talk, which is, again, another Serve talk that is going to be happening around 2:30, where Mahesh and Nitish will be talking about how are we untapping this data, how are we untapping the social aware navigation that we need to solve through end-to-end foundational models. So I'll highly encourage you guys to attend the talk so that you get a full picture of where we are, what we are trying, and where we are going next. With that, as everyone does, we are hiring. Please come talk to us. Happy to share more information and love to brainstorm on how you think to solve this problem together. Thank you.